This is a talk which wasn't scheduled originally. I was asked to give it because some other speaker had to cancel. But it's a talk that I gave at work, and it normally lasts about an hour. So it's going to be difficult to fit it into this time slot. Therefore, we may not have time to get through it all. But if you give me an hour after the talk to update the notebook, then the updated version will be available at that URL. The QR code does work. The only changes I've made are updates for Python 3.13, where there were various errors that were recategorized, and so we got different exceptions. But don't worry about that. If you want to download it straight away, it will work on Python 3.12, I believe. So let's get into it. First of all, who knows how Python resolves unqualified names? Hands up. Nobody knows how. I don't believe that. Okay, so if it finds a name, then it first of all looks in the function's current local namespace to resolve it. If it can't find it there, where does it go next? Oh, we've got some beginners in the room. Okay, if you can't find it there, it then goes to the namespace of the module containing the function. We call it the global namespace, but of course they're global to each module rather than being global across the whole program. If it can't find it in the global namespace, then it looks in the built-in namespace. And what happens if it can't find it in the built-in namespace? Indeed, it raises a name error exception. Now, when you get nested functions, nested classes, that kind of thing, particularly lexical nesting, that does create some complexities which we're going to completely ignore because they're not really relevant. So this talk really begins at the point where we have looked up a name. We've got a reference to some object that we found by resolving the name O. So supposing we want to access the attributes of a particular object. So supposing we see the expression O.x, first of all, the interpreter resolves the O by the means that we've just described, and then what does it do? Well, the answer is that qualification to a first approximation, by the way, is rather important, but until you understand descriptors, then this will do, until you start using descriptors, this will do as a top-level description. So first of all, it will look in the namespace associated with the object O. If it doesn't find it in the instance namespace, it looks in the instance's class. If it doesn't find it in the object's class, then it looks in the class's superclass, and it keeps ascending the class hierarchy to try and resolve this attribute name. Eventually, it gets all the way up to object, from which everything in Python inherits, and if the search fails there, then you get an attribute error exception. But things are just a little more complicated than that. So there is a built-in function, dir, which you've probably all used, and that conveniently bundles together all of the names, well, most of the names that are accessible. But there are various dunder names that are common to all objects because they're inherited from object. And so I've written a convenience function, and I'm sorry, I couldn't find a way to make the code appear larger here, so you may well need to go to the URL to be able to, the GitHub repository, to see the code. But basically, all I'm doing is if I'm given an object, then I take its dir and I simply omit all of the names that begin and end with a double underscore, the so-called dunder names. So here's a simple class. We've got a class variable and an instance variable. So demo object there has an instance variable C, which is an integer and has the value 42, a class variable. And it has an instance variable which is assigned inside the init function. And so if I create an instance of that class with demo object 21, then we should see that because of the what's happening here? Hang on a minute. Yes, okay, I've just created the instance. So because of the name search protocol, you can reference class attributes as though they were instance attributes. So if I ask for the values of O.V and O.C, O being an instance of the class, then it will resolve the O.C, which you'll remember is a class variable, just like it belonged inside the object O, as though it was an attribute of object O, even though it's actually an attribute of the class that O belongs to. So some attributes will appear in the instances dunderdict, others will appear in the classes dunderdict. It depends on how the assignment is made. So if I look at the dict of that demo object, then you can see that C is in that class variable list, along with dunder init, dunder static attributes, dunder dict, all the dunder names are there. But there's also a value for C. So that's the value of the class variable C. Now, if we look at the names that are available inside the class, you can see that when we remove all the dunder names, only C remains. So if I look inside the instances dict, then I see the value for V inside the instances dict. So if it's not in the instances dict, we look in the classes dict, we look in the classes dict, we look in the classes superclasses dict, and so on, until we either get to object and can't resolve it, or we find it. So although attribute access does follow the class hierarchy, attribute assignment doesn't. When you bind a name to an instance, then name binding takes place in the namespace of that object. So once you've bound a name in the local namespace, because of the method resolution order that we were describing, ascending the hierarchy of classes, once a name is bound in the local namespace, then any class variables of the same name will become invisible. They'll be shadowed, because once it tries to resolve the attribute name, it will immediately find it in the local namespace, and so it won't bother to look in any of the classes. So here you can see I'm binding the value 43 to the name C inside the instances namespace, and so that adds a C to the instances namespace. And so if I now look up the instances C value, I get 43. But if I look at C in the instances class, that is the class variable, I can still see that 42. It's just no longer accessible because the name is resolved in the local namespace instead. So the descriptor protocol is, among other things, the mechanism that underlies the property aspect of Python. And the descriptor protocol is basically anything that implements a dunder get, dunder set, or dunder delete is assumed by Python to be a descriptor. So let's write a function that tells us whether or not a particular attribute is a descriptor. And that's relatively easy. Basically, I take the list of names that are available inside the class, dirp, and then I look to see whether any of those names are either dunder get, dunder set, or dunder delete. And if they are, then that expression there will be the return value of the function, and it will return true. So now we've got a particular function called isDescriptor that will return true if any of those methods are defined. So rather than using a property decorator, which we could do, and many of you may have done to achieve this, we're going to build a descriptor from scratch. And I'm going to start with just a get method, a dunder get, no dunder set, no dunder delete, making it what used to be called a read-only descriptor, and for reasons that I'll explain later, is now called a non-overriding descriptor. So here's a class, and we're defining the dunder get. And you can see that there are three arguments to get. There's the self argument, which always applies to methods. There's the object, and there's an object type. And we'll ignore the object type for now. So the first thing this function does is basically tell you what it's working with. So it tells you the object and the object type, and then it just says, I'm a D1. So it'll always return the value, I'm a D1. Now, if we use that on its own, we don't actually see the descriptor magic happening. So if I create an instance of D1, and I then and I then access it as a value, it just says I'm an instance of D1. So the descriptor instance isn't actually doing anything special in that case. It just behaves like a normal class. So the descriptor protocol comes into play when you create an instance of the property class as a variable, as a class variable. So if I write a class, and we have a class variable called D, whose value is an instance of the D1 class I just showed you. In other words, it's an instance of a class that has a dunderGet method. So if I create an instance of that called C1, and I then access C1's D attribute, then you can see that it actually does call the dunderGet function. We see the output from the dunderGet. It tells us what the object that we called it on is, what the object that we're calling it from is, and what the type of the class is. And of course the value is the return function value from dunderGet. I'm a D1. So let's examine the namespaces of C1 and its instance. Will you give me a 5-minute flag, by the way, when it's time? Yeah. Let's examine C1. And sometimes when you're dealing with these things, you have to be careful not to trigger unwanted descriptor behavior when you actually want to look at what's going on under the hood. So if we ask C1 class what class variable names it only has D if you throw away all the dunders. So now I'm going to create, this is asking an expression value. So here we've got a 4-element tuple. The first element is the type of the D entry in C1's dict, and that's the complication that we have to go through to avoid triggering the mechanism. I ask whether that is a dictionary, I ask what its type is, and I ask if it's a descriptor. So it's an instance of main.d1. It's true, it is in fact a descriptor. The type of the value is string, and c1.d, you will note, is not a descriptor because there the descriptor mechanism has come into play. We've accessed a descriptor which is a class variable, and so the descriptor mechanism triggers, and so c1.d is not a descriptor, even though c1.dunderdict of d is a descriptor. So that's the difference between accessing something as a class variable's value and letting the descriptor mechanism take play. So with the D2 descriptor, we're doing much the same thing, but we're adding a value. So we can initialize that to any value that we want by instantiating the class with a single argument which will be assigned to the self.v instance attribute. Here's another descriptor function which actually shows, another function which will show you which descriptor functions a particular method instantiates. So I simply look through the list of names, and if I find a name in there, then I will print it. So if I ask for the descriptor methods on D2, we can see that it has a get, it does not have a set, it does not have a delete. It's a read-only or non-overriding descriptor. So if I now create a new class C2, and I say that its class variable D is an instance of D2, and it's actually D2 with the value 42, then if I create an instance of that class, and I then access its D2, the descriptor protocol triggers. It says, I'm getting dunderv, which I don't know whether it was obvious, but the class is using dunderv down there. That was an attribute dunderv. So back to where we were. Sorry about this. There we go. So it's getting dunderv from the C2 object, that is the class, and it's got a D2 whose value turns out to be 42. So it's no longer a constant value, it will return whatever value you created when you initialized it. So since there is no dunderSet method, assignment isn't overridden by the director, and so it makes by the decorator. And it directly enters the value into the class's dict. And similarly, because there's no dunder delete, you can't destroy these things. You can't use the del statement on them. So here's an attempt to delete it. What happens when we delete it is that we get an attribute error, and it says the C2 object doesn't have a D attribute. Well, we know it does. It's simply that we can't delete it because it doesn't have a dunder delete method. Okay, so if I now assign a value to the class's D variable, then if I look in the class's dict now, D is no longer a descriptor. It's simply that literal value. So because I've assigned to the class variable has no dunderSet, and so therefore the standard assignment mechanism takes place, and the name D inside the class is replaced by the value. So because the descriptor's non-overriding, that last statement has made a dict entry which is used to return the attribute value without calling dunderGet, because the descriptor's non-overriding, and so therefore it's stopped being a descriptor now. So if I ask for the value of the class variable, it tells me that it's 2345. The descriptor protocol's gone because we've shadowed that name in the local namespace. So when we add a set method, dunderSet, I'll miss out the dunder from now on. Basically, D3 is the same class as D2 with the addition of a dunderSet method. And as you might expect, it takes two arguments besides self, the instance that we want to change and the value that we want to change it to. So in this case, it will actually change the value of the the underscore v local instance class variable. So what descriptor methods does this class have? Well, the answer is that it has both a dunderGet, a get and a set. So if we create a class C3 which has an instance of D3 as its class variable, and we create an instance of the C3 class, then when we access its D value, you can see that the descriptor method comes into play, and then it returns the initial value that we created it with when we created the class variable up in cell 31. So if I now assign to C3's D, this is where things change, because now we do have a dunderSet protocol, and so because we have a dunderSet protocol, it's actually changing the value, and then when we ask for the value, it says, well, the value is now changed. So what's happened there is that the dunderSet operation has been called. So when I opened the talk, I described what's usually given to beginners as the way Python works, as the way it resolves names. But the reason that the descriptors with a set are now called overriding descriptors is because they override the standard mechanism which existed until descriptors were introduced. So before it searches for any regular instance or class variables by looking in the instance and the class and the superclass and the superclass and so on, before it does that, if there is an overriding descriptor, then when the name is used as an attribute of the instance, even if there is an instance variable with the same name, because the descriptor protocol for setting overrides the standard process, even if there's an instance variable with the same name as the class's property, they will nevertheless still use the class property. You'll remember normally I said when you assign inside a class's namespace, then it just assigns a value. But if you have a set attribute, a dunder set attribute in your descriptor, then the descriptor protocol says, aha, this is not a standard class variable. This is a descriptor that has the ability to write new values, and so it calls the dunder set method before it starts looking through the class hierarchy. So here's a new class which defines dunder get and dunder set, and now it actually tells you what it's setting the value to. So I create a new class with a D instance variable of the class that we just defined up there, and then I create an instance of that class. And now when I set the D attribute to some new value, then it actually triggers the dunder set, and it says I'm setting dunder dn in the cn object to 1, 2, 3, 4, 5. So the descriptor protocol has been initiated. And similarly, when we access it as a standard class variable, then it just uses the descriptor protocol again, and it says I'm getting dunder dn, sorry, underscore dn from the instance. So if I look inside the classes dictionary, sorry, the instances dictionary, then I see that there is indeed a value called dunder dn, and it does have the value 1, 2, 3, 4, 5, and that was written by the descriptor protocol. So if you studied the code of the dn descriptor fairly carefully, then you will see that the dn descriptor uses a specific instance variable, dunder dn, to save the values that are put inside that descriptor. So if we gave it two dn descriptors, if we said C equals dn, D equals dn, then they would both refer to the same instance variable. So that's a little bit tricky. There is an answer to this conundrum later in the notebook. I don't know whether we'll actually have time to get through it or not, which is why I put the QR code up in the first place, because you may want to continue this, or of course, you may never want to look at descriptors ever again. So properties are descriptors. And most programmers, or at least a lot of programmers, have heard of descriptors, even though they've never heard of properties. And they're very similar to descriptors, with the exception that because the standard property defines dunder set, dunder get, and dunder delete, they're always overriding descriptors, which is sometimes something that takes people by surprise. So now we understand that underlying mechanism. Let's just have a quick look at properties and see how they work. And if you actually ask for the help on property, you will see that it is a class. It has a function get, function set, function delete, and a docstring. And typically you'll use it to define managed attributes and so on. It's an easier way to use it than to actually describe the descriptors yourself. So you'll see that the property class itself doesn't have a dunder set, a dunder get, but that doesn't matter because the property class, the important thing about the property class is the instance variables in it. So properties define three decorators, and the three functions, function delete, function get, and function set, they are called from the standard del, get, and set methods when they are present. So a simple use of a property is to define a virtual attribute, or sometimes called a computed attribute. So here's a simple class person. I wonder if I can make that bigger. There we go. Here's a simple class person, which defines a first name and a last name, which are given as initializing values to the init. And then we've defined a property, at property. So property is, among other things, a decorator. Property is a decorator, and so it applies to the function full name, and the full name property, when it's accessed, will return the first name, a space, and the last name. So if I create a person whose first name is Steve and whose second name is Holden, then the full name will come back as Steve Holden. So that's the standard property mechanism which underlies, which is underlied by the descriptor. Okay, so any reference to a property as an instance's attribute will cause the property's dunder-get to be called, and that will return the value of the attribute lookup. So if I create, I've already created an instance, but if I ask what the type of its full name is, then it's a string. But then if I access the value, then there is the string, Steve Holden. But when you refer to the property as a class attribute, remember, that doesn't trigger the mechanism. The mechanism's only triggered when you access an instance attribute which has a descriptor in the class to underlie it. So in that case, if I access the person.fullName, then that's a property. And if I access it from the class, then it just says it's a particular property at a particular address. So remember, this mechanism only occurs when you're referencing instance attributes. So person full name doesn't allow us to change the value of the full name because there's no setter and there's no getter. It's simply a read-only computed attribute. So if we look inside that person full name's name, in other words, we look at the attribute of the descriptor. So remember, we're accessing it by the class. Let me just make that a little bit bigger again. Yeah, so we're accessing it by the class, and we're looking at the full name variable. So if I print out the name and I print out the type of the attribute, so I'm actually using getAttra there to reach inside the class and access things by name, then there is a list of the non-dunder names generated by or defined by the property. And so you can see that there is an fdel, an fget, and an fset, but only fget has a real value. Fdel and fset are set to non-type. Now there's also a deleter, a getter, and a setter, and those are the things that actually perform actions. So if I list what's inside the instance variables of the instance, then I can see that there's only first and last. There's nothing else. There is no descriptor attribute. If I ask for the names, then it says there's first, there's last, and there's full name. So if you remember, the names describes all the non-dunder names inside there. So if I now try to create a new value for that full name instance, were it a property, there would be no dunder set, and so it would raise one type of exception. But in this case, it's actually a rather more sensible exception, which just says it has no setter. So you remember, properties are always overriding, and therefore they will have a dunder set method, but that dunder set method is just a function that says there is no setter on this object. And similarly, if I try to delete it, it says it doesn't have a deleter either. So if a property is registered in a class, because it's a descriptor, it will take precedence over an entry in the instances dict, because properties always have the get and set method even when they, the set and delete methods, even when they don't actually do anything except raise an exception that says we don't have the right methods. So, in other words, it's not possible to override a property in the local namespace in the same way that it's possible to override a descriptor. So, in this case, if I try to change the value of the full name variable inside the instances dictionary by assigning it a new value, but in this case, don't forget, I'm actually subscripting the instances dictionary, the namespace in other words, then what happens? Well, the answer is, now I have actually managed to overwrite the value in the namespace in the local, I've put a new value in the local namespace, so even though the property exists, we do still see the original. So in other words, having changed the dictionary to include a full name in the local namespace, because properties are overriding, as an instance variable, they still aren't seen. So in other words, properties as instance attributes don't invoke the descriptor behavior. Well, I think since there's only a couple of minutes to go now, we should probably call it a day at this point. But there is, as I will briefly show you, a lot of more material inside the slides, including a little bonus material. So if you want to take it further, then there is some further reading that you can do. Hopefully anybody who's interested has got the QR code, and if we've got time for questions, I'll be happy to take them. Thank you.
Any questions?
So clearly it was an entirely clear and comprehensible description, and nobody has any questions. I don't believe that for a minute.
Sorry to disappoint.
Go ahead.
I was wondering about what you said. Could you reiterate what you said about descriptors and not being able to have two instances of a descriptor on the same class instance?
Ah, right. Okay. Well, let me see if I can find the original definition of that class. That was the DN class, I think, wasn't it? Properties, so it's before DN. There we go. So, sorry, remind me of the question again, the specific point you wanted?
You mentioned something about not being able to have multiple instances of the same
right,
descriptor.
okay. So yeah, this is my little descriptor here. And so it's got a dunder set attribute, right? So it can set values, but it sets values by creating a local variable inside the instance called dunder dn, right? So if I add two dn descriptors to the same class, they'll use the same dunder dn instance variable, and they'll basically both access the same value. Does that explain it more thoroughly?
Even if they're different instances of the... even if they're different instances of the same...
Well, I
class,
should think so. Can I actually... No, you can't edit during...
Or is it a class variable as opposed to an instance variable?
Is it a class variable?
The underscore dn?
No, because when the setter is called, it's called with the object on which you're supposed to set it.
Oh, I see. Right.
So
okay.
that object is an instance of a descriptor class, basically. Yeah? Does that explain it? Good. Thank you. Anything else? Yes.
I'd like to continue on this topic. And does it also mean that if you have two different descriptors that share the same underscore dn name in their implementation, they would also collide?
Yes.
So like in general,
Yes.
if you have any two descriptors on a class,
Yeah.
it's tricky. Like you can get into like name clashes. Right?
Well, you can, except there is a mechanism for overcoming that, which is described later in the notebook.
All right, so there's more.
It's not really a problem. It's just that we haven't delved into the topic in sufficient depth to answer your question yet.
I see, thanks.
Any more questions?
Oh, one here. Did you wait until the microphone, then everyone can hear the question?
Could you just show the QR code again, please?
Would I show?
The QR code.
The QR code? Oh, sure, yes, good idea. Whoops-a-daisy. This is the one thing where RISE isn't terribly convenient. There is actually a menu you can access, but I've never found out how to do it. Da-di-da-di-da. Dee-da-dee-da. This was a long talk, wasn't it? There we go. How's that? Whoops. Bother. Hang on a minute. I'll see if it can go. No. All right. Make it a little bit smaller. There you go. And I suppose in closing, since there don't appear to be any more questions, I will just encourage you all to buy a copy of Python in a nutshell. Thank you.